All right, so our next speaker is Dr. Nawshad Haque, a very dynamic researcher, very collaborative, both academia and the fundamental research and applied research. Dr. Nawshad Haque is a principal research scientist at Commonwealth Scientific and Industrial Research Organization, Australia. He leads the techno-economic economics part of the decarbonization team and hydrogen energy research team, as also Professor Dr. Nikolai Kinab mentioned. With over 20 years of experience and a PhD in chemical engineering, he has driven several large-scale international research projects. He is a fellow of the Australian Institute of Energy and the Australasian Institute of Mining and Metallurgy, and has supervised 14 PhD projects and 56 undergraduate research projects under his leadership. Dr. Haque is also as an adjunct academic at Swinburne University, Monash University, and RMIT universities. He has initiated numerous international collaborative research relationship and leads the India-Australia Mineral Scholar Network to develop scientific research capability. Dr. Haque's mission is to utilize science for development and diplomacy. So with this note, I invite Professor Dr. Nawshad Haque to talk about carbon footprint of hydrogen energy system. Please.
Thank you, Professor Firoz Alam, for kind introduction, and good afternoon, everyone. Yes, I think yes, my presentation is. Can you share that one? So thanks, Harun, also. So I think I'm really pleased, and thanks for inviting me to talk here about this carbon footprint of hydrogen energy system, which is important. But also I can see that very good presentations so far have been made by all the speakers, particularly our colleagues and visitors from China. Jilin University is looking at, I was going to ask Professor Hu that about the fuel cell cars and also the electric cars. So transition is happening. It's a challenge for not only countries like Australia, we have a lot of energy, but those countries which does not have energy, they have got similar challenges. So it's a but at the end of the day, why we are doing it? We have got plenty of gas, plenty of coal, natural gas. I think Professor Kamrul Alam showed that. But we need to think about decarbonization. And at the end of the day, if we do lots of activities and create carbon emission, we need to know what is the net carbon emission. And that's what that life cycle assessment is all about. And I'm going to talk about that technique. I'm doing that over now 20 years. So I think that's hopefully that will move. Yeah. So I think I've been introduced. I'm not going to tell about myself, but essentially there is an event called TMS, the Minerals, Metals and Materials Society in the US. The TMS meetings is very famous, and they operate or they run every year in US cities, mainly in San Diego, but other cities. Next year, 2024, 8th of March, that will be in Orlando. So I think our students particularly I encourage, and anyone 4,000 to 5,000 material scientists and mineral scientists professionals, they get together. It's a quite big event, and I often meet a lot of Chinese and colleagues from India and other parts of the world. So I organize one event called Energy Technology and CO2 Management. So next year I'll go again. So I encourage you to explore, and TMS 2024. If you Google it, you will find it. And there are. I think they also provide support to attend for the students and other professionals. So I think Professor Kamrul Alam briefly mentioned just myself and Professor Firoz Alam and RMIT team. A RMIT team was in Dhaka, in Bangladesh a couple of weeks ago, or a week ago almost. So what we did, about 50 PhDs we are talking about. So that has been funded with. So we are kind of using our diplomatic channels or relationships to develop the scientific research capability, and that was in Bangladesh. That's a Karjan Hall, which is famous. I think Professor Alam was part of that university, studied and taught and came here. So that program will kind of create opportunities for professors in RMIT universities. So I'm just probably you can keep an eye for that. So I think I also yesterday actually landed last night, midnight. I'm still feeling a bit sleepy, I guess. So like our visitors from China too. I mean, you need when you travel around, you feel a bit of tired. I was in India also, so I met. So you can see that the picture is in Bangladesh event. Professor Kamrul Alam, myself, and Firoz Alam had a training, and Jeremy Brewer, who is the Australian High Commissioner in Dhaka. We had meetings. Also, I met Australian High Commissioner in Delhi, and also the in the middle Director General of the CSIR, which is like CSIRO in India. There are 40 labs, and Dr. Kalai Selvi, she is the Director General of this 40 labs, head of that one. So we had a bit of discussion about talking about how we can utilize science. And one thing increasingly becoming clear, particularly this kind of energy transition space, that we all countries has to work together. And it's a kind of, maybe US, they have a lot of money. I've seen that labs are really flashy with lots of scientists, but it's still scientific challenges there. So we all need to appreciate that. So I think I'm just probably I can tell a bit of life cycle assessment, how that can be applied in the context of hydrogen energy systems. And then in Australia, we have got a scheme called Guarantee of Origin scheme. I know some of our students will be presenting in the afternoon and have already done that. That's Australian system. That is the carbon footprint of hydrogen energy, because we are thinking there are so much effort. Nikolai Kainaev, who is my colleague, actually, this is one of the largest activities or research, you can say, that projects undertaken on hydrogen energy system in Australia, that is in CSIRO. Obviously, other countries are doing it, Japan, Korea. I've seen in India, obviously, now stepping in. Many countries have their hydrogen strategies, but he gave a very good overview what we are doing. I'm coming from, and majority of the projects he mentioned and technologies, I'm quite deeply involved. Some of them I'm loosely involved as a part of the team member. So what I'm seeing that obviously we're developing technologies, and a lot of people are selling that technology. It's a green technology, but what is the proof? And you need to, particularly hydrogen, once it is become a product, it will be traded globally, like LNG, like other kind of high volume fuel. They will run the world in terms of energy sources. But now, unless we know what is the carbon footprint of that, and it is established as a standard globally, that would be with difficulties. So that's what we are trying to develop, standards for hydrogen energy. What is the carbon footprint of that, essentially? And Australian Guarantee of Scheme is one of them. Other countries are developing, but we need to bring them together and in consensus, through consensus, I would say. So what is happening internationally? I'm part of some of these developments, particularly some global other countries. What is happening? I'll show some results and we'll finish it off, I think. Yeah. So why it is important? Because, you know, in what is called ESG, environmental, social, and governance, that is rating, ESG rating is becoming important. If you have a company, if you form a company, if you are in a stock exchange, your values can go up and down because of your ESG rating goes up and down. So particularly, we are talking about sustainability. Professor Kamrul Alam mentioned about COP. Although there is no agreement, but there are a lot of awareness in the stock market particularly. I've seen that if you look at some of the companies has got good ESG performance, they're doing very well. Or increasingly, that is kind of expectation that those companies will have good ESG rating, will do well. Unfortunately, industries lack skill in that respect. I mean, not only industries globally, not only in Australia, we have seen that shortage of that kind of technique. I mean, at the moment, we were discussing about climate change, all these things, but now we are quantifying. We need to know, because it's spread. I mean, some countries are, for example, emitting 100 ton of CO2, and that become, if you say $100 per ton, that becomes $10,000 we are talking about. So once something is converted to dollar value, and we are talking about mitigating, we are talking about loss, it has to be engineer, scientist, and good methodology should come to quantify that. So CSIRO is developing that tool. We are doing that for a while and developed a solid kind of capability. There are lots of software. It's a software heavy also. There are many software have been developed by various companies or external entities based on the government research. So CIMA Pro is one software called Gabi. I have used CIMA-Pro. I'm using that for many years. I've contributed to the development of some of the databases, not only myself, my colleagues and our team. And there are a number of flow sheeting software we use that's mainly chemical engineers use in oil industry, gas industry. It's called Aspen simulation suite of software. There are metallurgical simulations software and renewable energy simulation software called HOMAR. So all these software tools you generate lots of data and then use in LCA or life cycle assessment to know the carbon footprint. So when we talk about carbon footprint, as I was saying that there are a number of protocols. It's called WRI, World Resources Institute, and it's called Scope 1, Scope 2, and Scope 3 emission. So Scope 1 is I can in the diagram you can see that within that red, it's a kind of it's an analogy like if you have a house, whatever happening within your home, that's a Scope 1. But if you are going to take a tram, for example, that could be Scope 3. If you are buying electricity from the grid for your house, that would be Scope 2. So essentially, electricity purchased from the grid, that is Scope 2 emission. In your house, you can produce your own electricity, then that could be Scope 1. So there is a bit of definition for that one. So we are talking about life cycle assessment, and often we say boundary, that is start to finish, or what we call cradle to cradle, cradle to gate. So in this case, for example, hydrogen is produced in a sort of middle of boundary, we can say that is cradle to gate. So that will be Scope 1 plus Scope 2 plus Scope 3 upstream. And if you make a product, if you give it to someone and then someone will be using it, and that becomes Scope 3 downstream. Often Scope 1 and Scope 2 is relatively easy to calculate, but Scope 3 is difficult to calculate. So nowadays companies are mostly reporting Scope 1 emission. Some companies are separating Scope 2, but you will find difficulty to get good information about Scope 3. So that's probably about that. So I was mentioning about the softwares. I think I shouldn't take too long time, but some just understanding that those are internet available, particularly students. There are a lot of skills and jobs in this area, requirements, and then if you have a good software skill, potentially you can get a job for life cycle assessment. So mainly I was talking about CIMA-Pro, Gabi, which is now called LCA for experts, and there is also Open LCA. It's like Wiki of LCA. People are contributing and developing that software, but unfortunately that has got limited capability because it's not well developed as yet. So I think in terms of accounting technology, so in LCA, we call it, if you say bottom of that screen, that define goal and scope. That means why you are doing it, what is the boundary, how do you report, what standard you will follow. There is international standards also. Then you have got foreground data, we call it, and then you call it life cycle inventory data. Essentially, what goes in to make a product. For example, if you make hydrogen or produce hydrogen, you need a lot of electricity. Where that electricity is coming from? Is it from coal-fired power station? Is it from natural gas? Is it from renewable? And that need to be clearly accounted. And then obviously then you do life cycle assessment. So it's a quite complicated slide, but that I took from one of the consortium. We are working as a G20 countries, but essentially that has to be accounted for everything. So that another thing is that in Australia, it's called Australian Life Cycle Assessment Society, ALCAS. I was the director for that board for some time, and that's a professional society for Australia, and they have initiated, or they had an initiative called Australian AusLCI, or Australian Life Cycle Inventory Database Initiative. So you can see that because it encompasses every parts of the industry. You have got transport, you have got energy, manufacturing, building. So it is very data heavy. So essentially, you need to know to make, for example, energy can come from coal, gas, all these different sources, and transportation. So many different. It can be road transport, water transport, shipping, air transport. So those data has to be there. For example, you are producing hydrogen, then you are shipping to Japan. You need to know that intercontinental shipping, what is the carbon footprint of that. So that's lots of secondary data required. And so that's why, so that database has been developed and already under development. Some of the data are very good, some of not so good. So I think the various institutions working to develop the database. So that's one of the key part. So I think that's a hydrogen car. I think I drove that probably for a while ago, that you can say zero CO2 emission, it is written. So FCV stands for fuel cell electric vehicle. I think our colleagues presented already about the modeling of that FCV. So that is Toyota Mirai, and number of models, number of companies have got hydrogen cars now. So essentially there is a fuel cell there, there is a hydrogen tank, or I wouldn't say tank, it's a cylinder because it's high pressure gas cylinder. So hydrogen goes to the fuel cell and give the power, and then car can run, and essentially you don't have any CO2 emission. When that car, I think that's the number 1 or number 2 car in Australia. Now there are about 20 hydrogen cars. I think we have got one of them in our laboratory. So I think, but at the end of the day, if you, these are questions people ask. I drive a hydrogen car, I drive petrol car, or I drive an electric car. Which one is better? And how do you compare on a common basis? You need to think about from the start how all these products are made, how these fuels are made, what is the lifetime of a car, and then you can compare on a fair basis. So I think there was a task force we have developed, as I said, the G20 country for 1 year program that was in Japan, that was developed because G20 countries, although I don't think China is included in the list, but I know one of the Chinese institution is now part of that. I think very likely Chinese Academy of Sciences. So that was Dr. Amgad Elgoyani from Argonne National Lab was the chair, and I was the co-chair. So what we did, and there are all these countries you can represented, G20 countries essentially, you can see France, Japan, South Africa, India, Indonesia, and Canada. So what they contributed for what is the carbon footprint calculation system should be for a country, because every country has that different energy systems. In Australia, I think we saw that energy comes from coal, for example, natural gas, particularly electricity. And if you use that electricity to make hydrogen, carbon footprint would be different. But what we are talking about green hydrogen, which is, and hydrogen has obviously different color, they say, although hydrogen itself has no color, based on carbon footprint. So we are talking about renewable hydrogen, and how do we determine the carbon footprint of renewable hydrogen? Because you need to have, say, solar or wind infrastructure. You need to calculate that one. So that's why we wanted to provide a common advice to the G20 nations so that they can develop that scheme. We have more or less concluded that, and there will be new publication coming out of with all this guidance. So, and why do we need that? Because there is another IPHE, they call it, I think, International Program on Hydrogen Energy Systems. And again, different countries, they have to work together, share the data, and share the methodology so that we can have a good, robust framework and I think measurement methodology. So Australian guarantee of a scheme, we have got one form. Generally, the difference in terms of opinion between the countries is that some countries, they do not quantify, or what I say, they do not accept hydrogen other than renewable sources. That's the point, that if we are doing everything to reduce CO2, only the green hydrogen or hydrogen from renewable will reduce CO2. But in Australian context, we say, okay, you can make hydrogen from coal or from gas. In essentially our, like, we have got a lot of brown coal. We can make hydrogen from brown coal. But thing is that it will produce CO2. So if we can capture CO2 and do something with that, either you can sequester underground or make some other product from that CO2, potentially that hydrogen can be low CO2 hydrogen. But you need to have that quantification, and that's why that carbon footprint and determination is very important. So I think I just given one example. For example, it's recently, I think we did, as part of that G20 countries, we had to contribute to what we're doing. So you can see that one from the bottom, that grid connected PEM electrolyzer. So one kind of technology to make hydrogen, and that is very high CO2. You can see that 45 plus kilogram of CO2 per kilogram of hydrogen. So that's very high compared to solar or solar PV or solar PV means solar photovoltaic electricity. There are lots of solar farms in Australia. You know, last year, almost nearly 36% electricity came from renewable in Australia, and that included solar, wind, and hydro. And you can see that almost nil, nothing, because you are not burning anything. It's just so that's the very low CO2. On the other hand, a grid connected PEM, then grid connected alkaline electrolyzer, black coal gasification and hydrogen making, biomass gasification. So there are, I think, some of the technologies already Nikolai told. So what we had separated here, you can say that I talked about scope 1. So blue is the scope 1, so which is kind of significant part particularly any hydrogen made from fossil fuel, you will have definitely a lot of CO2. Scope 2, which is if you buy electricity, and you can see that, for example, grid connected PEM, so that essentially mostly scope 2 because you are purchasing electricity from someone or taking electricity and making your hydrogen. Whereas if it's a solar wind, almost no CO2. So based on that hydrogen CO2, they have made a kind of color scheme, which is okay, but I think they should have know that the actual number, which is the quantification, that's what we're talking about here. So gray hydrogen is from natural gas. It's now 97% hydrogen globally is made from gray hydrogen or natural gas essentially. Then you can have a black or brown essentially from coal, blue hydrogen, which is I was talking about like Australian situation, brown coal, and then you capture CO2. So still it's a low carbon hydrogen, I would say. Then turquoise, then pink, I think from nuclear. Pink is green hydrogen, which is source is biomass and water with renewable energy, electricity or renewable electricity. That's the hydrogen probably in the future. That green we are talking about, everybody will be asking for. And then you have got yellow, white. White hydrogen is that natural, which Nikolai mentioned a little bit like natural gas. There are some places that there are the concentration of hydrogen is higher, so you can extract like natural gas. So it's a kind of it's not, when we say hydrogen, it's not just anti-hydrogen. There are so many varieties, so many ways you can make it, and that's why understanding what is the net CO2 to the what we call oil to wheel. Say that car I showed you, if you inject hydrogen in that cylinder, what is the CO2 of that? That's very important because you need to so many processing steps you are using. So I think the key message is that quantifying carbon emission from processes or technology is very important steps in the context of hydrogen energy systems, because everything we are doing to decarbonize, unless we know what is the current and how much we are going to reduce in comparison with benchmark, then what's the point of doing it? And that's why standard methodology is required, and that's not only just one country, it's between countries and universal. And then sustainability is making sure that need of future generation is maintained, and that's ESG rating is very important. And life cycle assessment is a key tool it is an universally kind of acceptable tool. There are international standards, although there are databases need to be developed in the context of hydrogen energy systems, and that's what we are doing, and many other kind of groups are doing. And we all have a role to play, particularly developing new engineers and new generation of scientists that this is important and need to know that that is skill set required. So I think that's where I'm finishing. I think that's our other car I was talking about. And anybody interested, we're happy to host you to show you around what we're doing. Thank you very much for your attention.
All right, thank you. All right, so thank you, Dr. Nawshad Haque. We have a token of appreciation. That
right.
is a little certificate.
Thanks. Thank you.